In my last video, we talked about drilling the earth from one side to the other in a hypothetical way. In this video, I want to share the real-world effort to explore beneath the upper crust of the earth. The way there is a race to go to space among space agencies all over the world, and there is a race to dig inside the earth as well. Before going to the most recent advancement in digging down, let's learn the historical perspective in brief. The deepest man-made hole on Earth is Superdeep Borehole, which is 40,230 feet or 12.2 kilometers deep. It took 20 years to dig this far, from 1970 to 1992. The temperature reached 180 degrees Celsius, and the pressure was 4,000 times that at sea level. This was still 80 kilometers away from the mantle, the next layer. Due to such high temperatures, drilling was not possible after that. It was 1992, right after the fall of the Soviet Union. Funding was also not available for such projects anymore. Locals think they can hear the screams of the souls there. They call it the hell. The German tried drilling and left off after drilling 9 kilometers. One of the biggest challenges Germany found was to drill as vertically as possible to avoid the torque on the drill. Germany was able to drill first 7.5 kilometers vertical, and then it started to drift off the vertical line. The solution German engineers found to drill vertically became the standard tool in the oil and gas industry later. A Dutch artist, Lotte Givan, dipped his microphone with a thermal shield down the borehole, and the microphone picked up some deep rumbling sound. She said, "It was the first time in my life this big ball we live on came to life, and it sounds haunting." Germany wanted to go deeper than the USSR, but the place they were drilling was much hotter and drilling was much harder. The cost became a big issue as well. The German Continental Deep Drilling Program drilled down to 9 kilometers. The United States also participated in the race towards Earth's core, started with Project Mahole in 1961. The U.S. tried with a different approach and started the drill on the ocean floor because the Earth's crust is thinner in the ocean floor. So there would be less drilling and fewer challenges, but still, it was an unsuccessful attempt due to technical difficulties and also funding limitations. These were some previous attempts in the race to the Earth's core. Here comes some recent progress. That idea of digging through the ocean floor brought us some notable success. In the spring of 2023, an expedition effort led by the International Ocean Discovery Program was able to go the closest to the center of the Earth than ever before. They collected pieces of the Earth's rocky mantle from the Atlantis Massif, which is a mountain located beneath a mile from the North Atlantic Ocean floor. It is located in a special tectonic window of the Mid-Atlantic Ridge. The Atlantic Massif is comprised of mantle rocks that have been brought up closer to the ocean floor through ultra-slow seafloor spreading. The plan was to dig down 656 feet because the initial estimation was that after that drill, it might get ham. But nothing happened. So they kept digging up to 4,160 feet into the seabed, deeper than ever drilled. The core sample they pulled from there might have some clues to the origin of life on Earth. The core originated in Earth's mantle. We now have a treasure trove of rocks that will let us systematically study the processes that people believe are relevant to the emergence of life on the planet. Underwater habitats like Atlantic Massif interact with salty seawater and can produce hydrogen and methane that support microbial life and feed the small invertebrates in the ecosystem. Understanding the process on Earth will open the door for new knowledge in extraterrestrial life search as well. Understanding the composition of mantle rocks will also be important for learning more about the tectonic plates and volcanoes.